Okay friends, so welcome back to in this last session based upon this force voltage as well as force current analogy. So in this session we need to attend the second objective, that is nothing but what? When it is required for we people to draw the force current analogous circuit for this given mechanical system. So in that scenario also, just similar to the previous session, we used to have the three different basic steps. In that first step, we need to enlist the number of elements which are present into this given mechanical system. So as there are two identical masses, two springs and two dampers, right? Then after that we need to focus on these things. There are how many number of displacements, because in that nodal diagram the number of nodes equals to number of displacements. Number of displacements equals to number of masses. So already as we are having two identical masses, so these two are the displacements x1 and x2. We are having two springs and two dampers, right? Out of these two springs and out of these two dampers, first two elements are connected in between x1 and x2. So in this way these elements are to be shown in this nodal diagram, right? So the nodal diagram is already being drawn. In this nodal diagram there are two node potentials. This is the first one x1 and this is nothing but what? X2. Number of nodes equals to number of displacements. Then after that, at this node there are 1, 2, 3 and 4 branches. Out of that 4 branches we need to use this Kirchhoff current law. Kirchhoff current law says that summation of incoming currents equals to summation of outgoing currents. So in terms of forces, this first branch represents the direction of applied force which will be incoming to that node. As far as the remaining branches are concerned, so their forces, the concurrent forces, are outgoing from this node. Similarly, at this node there will be five branches. Out of these 5 branches, the branches belongs to K1 and B1 already, which are being included in that first node, are incoming to this X2. So the forces belongs to these 3 branches M2, K2 and B2 are outgoing for this outgoing from this node. So in this way this nodal diagram is to be drawn, right? Then after that what we need to do, similar to the force voltage analogous technique, we need to recall the analogous terms belongs to these 3 mechanical systems: mass, spring and damper. So in case of force current analogy, force is analogous to this current, this mass is analogous to C, damper is analogous to conductance, the reciprocal of resistance, right? This spring is analogous to the reciprocal of inductance 1 over L, right? And similar to this force voltage analogy, here according to this Faraday's law, this V equals to what? The rate of change of flux per unit time through that electrical elements, right? So accordingly this X is analogous to this phi, right? So by taking into account this fact, one more time we need to write the system equation here. Okay, so after applying the Kirchhoff current law, the system equation will be what? The system equation at node number 1, here I will write F equals to F is the incoming force, the outgoing forces are the branch belongs to M1, B1 and K1. So at the same time we need to recall the force equilibrium equation for this mass. So it will become M1 into d square x1 upon dt square plus K1 is associated with x1 as well as x2, so it will become x1 minus x2 plus, similarly B1 stands for what? Damper, first order differentiation, d by dt followed by x1 minus x2. So in that next step what we need to do, definitely we need to apply the Laplace transform. At the same time we need to recall the analogous term. In case of this force current analogy, force is analogous to current, M is analogous to C, damper is analogous to conductance, reciprocal of R, K is analogous to L, and X, displacement, is analogous to the desired flux phi. So as a result of this it will become what? After applying this Laplace transform, it will get converted into S domain. So analogous term will be what? F is analogous to S, F is analogous to I, force current analogy, I of S equals to M is analogous to C, so C1 into Laplace variable will be S square followed by X is analogous to phi, S square into phi 1 of s, here I will write, plus k is analogous to 1 over L, 1 over L into x is analogous to phi, so it will become phi, here I will write, it will become phi 1 of s minus phi 2 of s. I will put this term into this parenthesis, plus b is analogous to what? B is analogous to 1 over r, reciprocal of r, conductance, so it will become 1 by r1, first order differentiation Laplace variable s. X is analogous to which term in this force current analogy? X is analogous to phi, so it will become phi 1 of s minus phi 2 of s. I will put this term into this square bracket, right? Then after that, initially this v is nothing but what? D phi by dt. So when we apply the Laplace transform, so it will become what? V of s equals to s times of phi of s. So we need to replace this s times of phi of s with this v of s into this existing statement. So as a result of this, if suppose this statement can be called it is as a capital A, so I of s equals to s into phi of s is nothing but what? V of s, so it will become c1 s into v1 of s plus s into phi of s, we don't have this s term, so it will get divided 1 over L, right? L is nothing but what? This 1 over L is analogous to k, so basically which k it is? K number 1, so L1 here also 1 over L1 times of s into v1 of s minus v2 of s plus, because q is here, this x is analogous to phi, right? And when we apply Laplace transform to this substitution, it will become what? V of s equals to s into phi of s. So phi 1 of s minus phi 2 of s, obviously it will become v1 minus v2, then remaining it is 1 over r1 into s into phi is nothing but what? V, so it will become v1 of s minus v2 of s, right? Now instead of calling it as a capital A, this is the equation number capital A, right? So in this same manner, we need to obtain the system equation at node number 2. Okay friends, so when we apply this Kirchhoff current law at this node number 2, so at that node number 2 there are how many branches? 1, 2, 3, 4 and 5. So out of that 5 branches, the forces belongs to these 2 branches are incoming towards this node. Already it is being assumed, right? Because its direction will be all from x1 to x2. As it is x1 to x2 means by default it will be incoming towards this node x2, right? As far as the remaining 3 branches are concerned, so their direction will be outgoing from that node, that we need to assume, right? So accordingly, its KCL equation in terms of forces will become what? Initially we will consider this K1. So here I will write K1 associated with x1 as well as x2. So it will become K1 into x1 minus K1 times of x1 minus x2 plus this B1, right? B1 force equilibrium equation, first order differentiation d by dt followed by x1 minus x2, right? So after that, to the right hand side of this assignment operator, we need to write the force equilibrium equation belongs to m2, k2 and b2. So force equilibrium equation for m2 will be what? m2 into d square associated with x2, so d square x2 upon dt square plus k2 into x2 plus that is nothing but what? B2. So B2 into d by dt followed by x2, right? So in that next step, what we need to do, we will try to replace this mechanical element with this analogous term. Along with this x is no more, it is being replaced with this desired flux. So as we know, this k is analogous to 1 over L, so it will become 1 over L1, right? And at the same time, we are supposed to apply the Laplace transform, friends. So that simultaneously we are supposed to perform the 2 different steps. the replacement of mechanical elements with this analogous term, and we are applying the Laplace transform. So it will become K1 is analogous to L. So which K it is? K number 1. So it will become L number 1 over L1 into X is nothing but what? Phi. So phi 1 of yes. One more time. Phi 1 of S minus phi 2 of S plus B is analogous to 1 over R, reciprocal of R. So it will become 1 by R1, right? See, one more time, due to lack of space here I will write K is analogous to 1 by L. So it is K1. So it will become 1 over L1 into phi 1 of S minus phi 2 of S plus B is analogous to 1 over R. 1 by R1 into d by dt, first order differentiation, S into phi 1 of S minus phi 2 of S equals to what? This M is analogous to C, so which C2 S square into phi 2 of S plus K is analogous to what? 1 over L, so it will become 1 over L, X is analogous to phi into phi 2 of S plus B is analogous to 1 by R, so it will become 1 by R2 first order differentiation, 1 by R2 times of S into phi 2 of S, right? So this is how this equation is to be written. Okay friends, so this equation can be treated as an equation number capital B. Now carefully just try to see the different coefficients belongs to equation number of capital A and capital B. Equation number capital A written for I of S. Here the coefficient for the C1 apart from this Laplace variable as V1, the coefficient of L1 is nothing but V1 minus of V2. The coefficient of 1 over R1 is nothing but what? V1 minus V2. In that equation number capital B, this term is same as compared to capital A. Coefficient of L1 is nothing but what? Phi 1 of S minus phi 2 of S. So at that stage we need to replace this S into phi of S with this V of S. So it will become what? As we don't have a S term, so it will become 1 over L1 times of S, 1 over L1 times of S into V1 of S minus V2 of S plus 1 over R1, S into phi is nothing but V, so it will become V1 of S minus V2 of S equals to, here I will write equals to C2S into V2 of S plus 1 over S, we don't have S term, L2S into V2 of S plus 1 over R2 into S into phi is nothing but V. So that can be called as a capital C. So from this equation A and capital C, coefficients are nothing but what? As I told you earlier, 1 over L1 V1 minus V2, 1 over R1 V1 minus V2, just similar to the capital A. To the right hand side of this assignment operator, these are the three equations belongs to these three elements associated with this x2 and ground surface. Their coefficients are V2, V2 and V2, right? In that force current analogy, we used to have the common term as a current, right? If the current is common, so these elements are connected in series form, right? If voltage is common, so obviously these elements are connected in shunt forms, right? So accordingly, here as far as this equation number capital A is concerned, right, that whole equation is written for this I, fundamental current. So the first element we are having with us is nothing but what? C1, right? So it is to be shown in this way. This will be the C1, right? Then as far as this L1 and as far as this R1, these two elements are concerned, so there will be the involvement of V1 as well as V2, right, in this element, right? So how these elements are connected? See, if suppose this is nothing but what? C1 okay friends, so from this system equation, the force analogous circuit will be what? As the coefficient of C1 is what? V1, so it is connected in vertical arm because in that equation number capital A, that equation is to be written for this current I. So the tendency of that current is to get divided in that different branch. Those are connected in shunt form. But as far as this L1 and R1, these two elements are concerned, their coefficients are nothing but what V1 minus V2. So associated with these two displacements, as a result of this, it will drawn like this. This will be L1 and this will be R1. This is L1, this is R1, and this is the current source, right? Then after that, as far as equation number capital C is concerned, first two elements are already it is been shown. The remaining three elements are the coefficient of C2 is V2, coefficient of 1 over L2 is V2, and the coefficient of R2 is also V2. So these three elements are connected in shunt form, right? As they are sharing the similar voltage, means they are connected in shunt form. So this will be the C2, right? This will be the 1 over L. I will complete this circuitry like this. And the third element is nothing but what? The conductance 1 over R. So it is which are R2. This is nothing but what? L2, and this will be the C2, right? So this is how the force current analogous circuit will look like, right? Belongs to this mechanical system. If we see carefully, in that mechanical system there are two masses. So M is being replaced with this C. So this will be C1 and this will be C2. Then again important, B is replaced with this conductance reciprocal of R. So as there are two B's, so here as you can see there are two R's, R1 and this is nothing but what? R2. There are two springs. Out of the two springs, K1 is associated with X1 and X2. Here X is nothing but what? That can be replaced as a flux. Finally that is nothing but what? V. So this will be the V1 and that will be the V2. So these are associated in between V1 and V2. Then after that, this is the direction of current, right? According to this mechanical system. So this is how this force current analogous circuit is to be drawn. I just hope that you had understand all these things belongs to this force voltage analogy as well as force current analogy, right? So we will stop here. Thank you.